Greetings, fellow grade 11s. It's Mr. Sacha again. Look, now what we are going to be looking at today is we are going to, be looking at our November 2016 past paper, and we are still looking at the section of stoichiometry, right? Or rather, the quantitative aspect of chemistry. Now, let's start. Now look, now your 5.1. What does your 5.1 require you to do is to define what is the term concentration. And you know what I always say, please, whenever the question requires you to define, please ensure that you use the definition from your exam guideline. I repeat, you use your definition from your exam guideline, not any other, definition that you get around. So look, so now according to your exam guideline, your concentration is basically the amount of solute per liter of a solution. So we are saying concentration is the amount. So it's going to be the amount of what? It is going to be the amount of solute per solution. Solute per liter of a solution, per liter of a solution. Now, this is going to be your concentration. Now, please take it upon yourself that you learn and you understand this definition. Yes. Now let's look at then now 5.2. In 5.2, what are we then required to do? Now, they say 8 grams of, your Na, SO2 and O3 is dissolved in a water to prepare your 500 centimeter cubed of a solution. Calculate the concentration of it. Now, what is it that you are going to do to calculate this concentration? Look, now there are many ways that we can do in this, but look, if you can check, let's start here. What you have here, it is your V, and now what you have here is your grams, which is your mass. And from this particular formula, you can calculate your molar mass. I mean, so surely there is a formula that we can use to just calculate the concentration from the get-go. Look, you can simply say now concentration is going to be your M over your MV. Right? So therefore, we are going to say now the concentration. What is the mass here? The mass, you are given that this is 8 grams. And now what is going to be your molar mass? Now, your molar mass here, it is going to be your sodium, which is same as, look, your sodium, isn't it that this is 23 multiplied by 2 plus your sulfur. Let's just try and calculate this on the side and get our final answer. So we are saying now, look, our molar mass for our Na2 S2O3, it is going to be given by, let's add in here. Let's just try and add and see what is it that you are going to get. Now, from here, look, our sodium is given by what? Our sodium is given by your 23, I think. So your sodium is going to be your 23. Let's write here. This is same as your 23 multiplied by 2 plus what is going to be your sulfur in here. So if you are looking for sulfur, it's same as 32.07 multiplied by 2 again plus your 16 multiplied by your 3. So which means what is going to be your molar mass here? So the molar mass that you're going to get here, if we can just punch this in our calculator. Let's see. Now, if we plug this in our calculator, the molar mass is going to be 156. 156, right? Grams per mole. So this is going to be the molar mass. So which means here we are going to have what? We are going to have 156 multiplied by your what? Remember the volume here, it is given in centimeters and we want it in decimeters. So this is going to be now 500 divide by 1,000, and this is going to give us 0.5. So this is going to be 0.5 moles, or not rather moles, but decimeter cubed. So which means now what is going to be the concentration that we are going to have? This is going to be same as 0.10 mole per decimeter cubed. So this is going to be the concentration of this particular thing. Now let's Let's then look at your 5.3.2. Now we are in 5.3.2. Now the first thing they want us here is to define what is an empirical formula. I think now we know that your empirical formula, it is your simplest ratio, right? We know that it is the simplest whole number ratio between the elements of a compound. So empirical formula is the simplest. So let's use this. It's going to be the simplest ratio between the elements in a compound, between the elements in a compound, the elements in a compound. So basically that is going to be your empirical formula definition. Now then let's continue. Let's look at now your 5.3.2. 5.3.2. Now for this one, let me just try and get another nicer color there, right? Now here they want you to determine what is going to be the empirical formula for this. Look, preferably, what I usually do for empirical formula is that I like representing these things in terms of steps, right? So let me just write in here my table. So I'm just going to show you in terms of how can you also represent this. I know that different people, approach these things differently. So, but now this is what I am going to use. We are going to start here. So this is going to be the steps that we are going to follow. And this is going to be your this is going to be your compounds. Let's see in terms of what are we given. So they say a 10 gram a 10 gram sample contains potassium. It is also contain chromium, which is 3.54 of chromium, and also 3.81 of oxygen. So you're going to come here and say, look, we have what? Firstly, you have chromium. Rather, we have potassium, then you have chromium, then you have your what? You have your oxygen. So which means now, what is the first step? Now, the first step, you are going to now, your step one, you are going to write these things, you convert it in grams, right? If it's already converted, then you write it in grams. So now what is the grams of each? Now your potassium, what is your gram of potassium? It's 20, it's 2.66 grams, and the one for your chromium, it's 3.81, and the the other one, not necessarily. This is 0.54. The one that I wrote, it is for oxygen. This one is 3.54. And for your oxygen, it is 3.81. This is going to be the grams. Now, let's underline in here and see what else can we do. Now, then your second step, your step number 2. Now you're going to calculate what is going to be the number of moles. And remember, for moles, you use the formula mass over the molar mass. So now what is the mass of our potassium? We said this is 2. To do it, we are going to try and convert this or write these or find the mole of each and every, all the atoms in here. So now what are you given here? So the mass that you are given here, it is 2.66 grams over now what is going to be your molar mass of your potassium. So we know that the potassium is number 2, it's number 19, and it's going to be 39, right? So it's same as 39. So here this is going to be your 39. And when you are looking for this answer, when you say 2.66 divide by your 39, let's see. Now remember, let's just verify. Yes, this is going to be 39. And now when you say 2.36 divide by 39, what is it that you're going to find? This is going to be same as 0.068 mole. Now this is going to be that. Now when you come to the second one, what is it that we are also going to do? Now we are going to look for the one of your what now? We are going to look for the one of your chromium. Your chromium, you are having 3.54 divide by what is going to be your molar mass of your chromium, basically. Your chromium, let's check our periodic table. It is going to be a 52, right? So this is going to be 52. And when you say now this, you're having 3.54 divide by your 52. What is it that you're going to get? The mole that you're going to get again here, it is going to be same as it's going to be equal to 0.068, isn't it so? 0.068. And this one again, mole, then this one you're having 3.81 divide by what? Divide by 16. And what is it that you're going to get now? 3.81 divide by your 16. What is it that you are going to find there? You are going to find this as 0.238, right? Let's just write that 238. And now after this, hopefully this space of ours, now we are going to find out the ratio. Now, how do you find the ratio? You are going to look for the smallest mole and divide everything here with your smallest mole, right? So look, you are going to say, now what are you having here? You are having 0.068, and 0.068 is also one of the smallest ratio, right? Or rather the smallest mole. So you're going to say 0.068 divided by 0.068, and you're going to get this as your 1. And now your answer is going to be your 1. And now again, when you come back here at 0.068, you divide by 0.068. The answer that you are going to get here, it is also going to be close to your 1. And now if we are looking at the other one now, so here, what is it that you are given? You are given that you are having 2, this is 0.238 divided by 0.068. Now, what is it that you are going to find here? So similarly here, what you are going to find, you are going to find this as, let's see, divide by 0.068. Now when you divide this, you are going to find your answer as 3.5. This is going to be 3.5, right? That is going to be your answer. And now, then we are going to represent this in terms of ratio. Now, look, if we represent this in terms of ratio, what is it that you are going to do? Now, look, you're having 1, and the other one is what? It is 3.5. And you know that 3.5, it is not the perfect ratio that we can use. So what we can do is you are then going to multiply with your simplest ratio. You're going to multiply by 2 everywhere. So now if you multiply by 2 and 2 and 2 here, so that here you can also have the whole number. So which means the ratio here is going to be 2 is to 2, and the last one is going to what? It is going to be 7. The 7 is for this last one, right? Now this is going to be your ratio. So now, which means now your empirical formula that you are going to have now here, it is going to be what? Now look, what is your potassium? Your potassium, it is 2, and your chromium, it is what? Your Cr is 2, and your oxygen is going to be what? 7. So this is therefore going to be the representation of your empirical formula for this particular question. All right, now hopefully this makes sense. Now let's attempt question 6. Now here in this question, now let's start here. They're saying learners made a mini volcano in a science laboratory by adding your sodium bicarbonate to an ethanoic acid. They added 100 ml of 0.2 moles per decimeter cube of ethanoic acid solution to 10 grams of your NaHCO3. And now to start the reaction. Now, what is it that we are going to do now? The first question requires us to what? To say now, define what is going to be the limiting reagent, right? Or the limiting reagent, yes. Now, good people, I think we've spent tons of time, explaining this, but let's explain it again. Now, we are saying our limiting reagent, remember, in simple terms, it is going to be that particular reactant that runs out first within the particular reaction, right? So we are saying now your limiting reagent in this case is going to what? Limiting reagent in a reaction is that one that is going to be consumed completely. Now this is going to be, now we are saying a limiting reagent in a reaction is the reactant. It is going to be the reactant that is consumed completely, which means the one that runs out first, right? That is consumed completely. And then now what does this now give us? So which means it also determines the maximum, or it determines the maximum amount of product produced, maximum amount of product produced. Now, because product produced, because remember, when it runs out produced, so remember that when it runs out, there is no way that the reaction can continue now to to take place. So that's the reason why we are saying it is the one that basically determines which maximum amount of product is going to be it is going to be formed. Yes. Now let's look at your 6.2 now. In 6.2, they say determine the limiting reagent in this reaction. I know most of you find this very difficult. One of the key things that you need for you to determine which one is going to be the limiting reagent and which one, let's say sometimes they want you to calculate what is the excess. The first thing that you're going to use, you're going to need the moles of everything that you are determining. So you're going to need the moles of actually your reactants. So which means now if you can be in a position to calculate the mole of this one and the mole of this one, half of your work is actually completely done. Now let's see in terms of what is it that we are given. Now, if you can start now, the question say, learners made a mini volcano in a science laboratory by adding sodium to a bicarbonate. Now, this is important. They said they added 100 ml of 0.2 moles per decimeter cubed of ethanoic acid. You get that one. So now, what is important is now already we have some things that we can use here for ethanoic acid to calculate the moles. Look, remember that whenever we are measuring the volume can either be measured in decimeter cubed, or we can then convert also the milliliters to liters, right? So which means what is it that you are going to do? We are going to start with this. You're going to say, look, your 100 divided by 1,000, it is going to give you what? It is going to give you 0.1 liters, right? And now, secondly, what is it? This 0.2, this is your what? This is going to be your concentration. This is going to be your concentration. So which means you can use the formula N is equals to what N is going to be equals to, or rather, let's write it this way, so that everyone is going to be accommodated. I know most of you don't like to write this from concentration. You are saying now, look, your concentration is equals to N over V. And now you say, look, therefore your N is going to be C multiplied by your V. The reason why I'm, deducing this so that you can see in terms of what occurred for you to get your N as the subject of the formula. Now, therefore, let's start. So which means now your N in this case, it is going to be what? Your N of your hydrochloric acid, which is the one that we are, or rather ethanoic acid, not hydrochloric, ethanoic. It's going to be what? It is going to be your H3COOH, right? Then this is going to be same as now concentration multiplied by the volume. So this is going to same as 0.1 multiplied by what? Multiplied by 0.2. And what is it that you're going to get here as your answer? You're going to get 0.02 moles, right? This is what you're going to get. And after that, you're then going to come back and say, for this other one now, what is it that you are given? Look, the question continued that now you have 10 grams of your NaHCO2. Now, which means now, what is it that you are going to do now here? Or rather, your bicarbonate, right? And now what is it that you are going to do now here? We are going to say, look, for me to calculate the mole of this reactant, what is it that am I going to do? We are going to say, look, now I'm given this as my grams. So which means I'm given my mass. And now already I can also be in a position to calculate the what? The molar mass. Now, so which means what we are then going to do, we are going to say, now look, from here, your mass that you are given for this one, it is 10. Divide by, now look, let's say and try and calculate this. This is going to be 23 plus 1 plus your 12 plus your 16 multiplied by 3, right? And now this is going to be your n. So which means we are saying now your n of your NaO CO3, it is going to be given what? The moles that you're going to find here, it is 0.12. 0.12 mole. Now you have answered the first part of the question. Now I said the next thing that you are going to do now here is that you are going to then now compare the ratio of this. Now they said this is a balanced reaction. And now what you know from a balanced reaction is that now you can compare and say, now look, if I have your your NaCO3 is to your what is to CH3 COOH, right? Now what is going to be the ratios of this? Now there are ratios here. Look, this one is same as 1 here and this one is same as 1 here, so which means their ratios is 1:1. So which means for this reaction to occur completely or properly, the number of moles that you're going to get this side must be equal to the number of moles that you get this side, because their ratio are the same. But now let's check. However, what you are having, this is a complete different thing. Now, the mole of your Na, this is going to be what you are given, that this is going to be 0.12, while the mole of this, now the first one that we've calculated is 0.02, right? So what does this mean? Now look, which means this one, it is the one that is going to be used up first, because look, you know, the mole, or rather your mole of your of your bicarbonate of soda, your mole of your bicarbonate of soda is going to be greater than the mole of your ethanoic acid, right? So this mole here, this mole here, it is greater than this mole here. So which means which one is going to be used up first? This one is going to be used up first, right? This one is going to be the one that determines what maximum amount of product is going to be used, because this one is going to be the one that runs out. And as soon as this one runs out, there is no way that we can continue with our reaction, right? So therefore, now you are going to then conclude that actually now, since this is the one that runs out first, you are going to then conclude now that, look, your CH3COOH is the limiting, is the one that is limiting. This is going to be a limiting reagent altogether. And why? Because this is going to be what? This one, it is the one that is lesser. So it's the one that is going to be used up first within this particular reaction. Now, then let's continue with this question. Let me just wipe in here, because some of the things that are in there, we might, you know, be required to use them in the following question. So let's just wipe in here and leave the ratios and everything that we've just calculated. Now we are going to calculate now for your 6.4, for 0.3, I mean. In 6.3, they say calculate the mass of the other substance in excess. The other substance in excess. So if this was your limiting reagent, then this becomes your excess, because it's the one that remains, right? Excess is the one that is available, the one that you still have excess of while the reaction is complete. Yabo? So which means, what is it that you are going to do now? We are going to say, now for us to calculate the mass, we are then going to come here and say, look, the one that was supposed to be used in this reaction, it was supposed to be 0, it is supposed to be 0.12, because according to the ratio, which means if this is 0.2 here, The one that is also going to be used here, it is 0.2, which means from this 0.12, you are going to still have something that is remaining. So you're going to say, now look, and now the mole, firstly, that is going to remain for this one, it is going to be what? You are going to say this is going to be 0.12 subtract your 0.02, because that's the only moles that is going to be used within this reaction. Now, what is it that you're going to find as your answer here? Now, you are going to say, look, you are having 0.12 subtract you 0.02. And what moles are you then going to get? This is same as 0.1. So this is the mole that is still in excess, right? This is the mole that is still in excess. Look at me not knowing the spelling of excess. So it's the one that remains, right? It is the one that remains, right? So if this is the one that remains, then now what is it that we are going to do? Yes, our spelling for excess is this one. Before you say I don't know it, right? Now look, now let's continue. Then now what is it that you are going to do now from here? Now that you have your excess, the one that is remaining, you are going to come back and say, now let me then calculate my mass, because that's what we are looking for. Then the mass of this one is going to be what? This is going to be, look, your mass is going to be given by what? You have 0.1 as your mole. And remember, this other time we calculated the molar mass of this. So the molar mass, it was 84. So what is going to be now? The mass in here, it is going to be 8. What is going to be remaining here? The mass that you're going to have here, it's going to be 8.4 grams, right? So which is going to be the mass that is going to be in here. So this is going to be 8.4. This is going to be your mass in excess. Then now let's look at your 6.4, and then we are done. Now the 6.4, they say now calculate the volume of your CO2 produced at what? At STP. You know, I just want to, show you something here. Now, look, for us to be in a position to calculate what is going to be our carbon dioxide, or rather what is going to be the volume of carbon dioxide, we'll come back to this reaction again. Look, from this reaction, the one that was used up first, the mole that was our limiting reagent, we are going to use it, which was the 0.02. We are going to use it to find out the moles of all these things, because that's going to be the mole that help us to determine the maximum product formed here, right? And since this is the one that is used up first, the reaction didn't continue together after the 0.02 mole were used, right? So the reaction did not continue. So therefore, it is important that now we take the 0.02, we contrast with every mole that we are looking for. Now we are going to come back and start with the ratio and say, now look, for your CO2, CO2 is going to be your what? And now the mole of the one that you had in the one that was used first, which is your CH3 COOH, right? Now, you are saying, since we are using this mole as our reference because it's the one that determines the maximum product of this reaction, we are saying, what is the ratio here? The ratio is 1:1. And what is the mole that you had here? It is 0.02, which means even the mole of your carbon dioxide is going to be 0.02 moles, right? So this is going to be also 0.02 mole, right? And then now that you have the mole, you're going to say, now they say this is produced at STP, right? Now, and since this now is going to be produced at STP, what is it that we are going to find? They want us to find the volume. And I said the only formula that you have at STP, it's N is equal to V over Vm. This is the only formula that you have at STP here in stoichiometry, right? So now, do you have the mole? Correct, we have. Do you have the Vm? This is your what? This is your constant. So now if you are not given, we are going to use the constant one. So which means the volume now of your CO2 in this case is going to be same as what? 0.02 multiplied by 22,4. Right? And now the volume that you are going to find here, the totality of it, it is going to be same as 0.4, I think this is 4.48 decimeter cube. And please ensure that you write the units every time you are required to do this. And now this is going to be the end of our question. So I think by now, at least you have an idea of how we approach our stoichiometry. Thank you very much.